to fly IFR, then they ask that you put the FAR 33 version, which is the 912S. The 912 ULS is the ASTM compliant version. Now, mechanics who wish to perform service and maintenance on the Rotax aircraft engines, if they're installed on an SLSA, must meet the training requirements specified by Rotax and utilize the correct tools and fixtures as outlined in the applicable Rotax maintenance manuals. This is very important, not just to meet the letter of the regulation, because most of the airframe manufacturers today, if not all, require you to follow the Rotax maintenance procedures and guidelines. So to be legal on a special light sport aircraft and to be safe, you need to have Rotax specific training. Now, on the airframe side, only mechanics that have an LSRM rating, which is a light sport repairman with a maintenance rating, or an AMP certificate, and you can also actually work on a special light sport if you are a repair FAA licensed repair station, can work on the special light sport aircraft, perform annual condition inspections, and you'll find in the manuals they will outline who can do what and what is required. I'm going to get into some details here on that. Now, when you're working on a special light sport aircraft, the maintenance manual will tell you what the requirements are for performing that maintenance. If that particular maintenance item that you want to perform is not covered in the maintenance manual, then you have to go to the airframe manufacturer and get procedure and approval to perform that maintenance. This is an example of a request for an avionics installation approval that Flight Design uses. You can't take a special light sport airplane to Gulf Coast Avionics and tell them you want a jam-up panel. You just want them to put in all this great avionics, which you could do in a Cessna 172. You could go to Gulf Coast and tell them what you want, and they can do it, and they can do all the paperwork, and out the door, and you're set. You can't do that with a special light sport. The actual airframe manufacturer has to approve the installation of all the avionics. So if you want something different than what's on your approved list, you have to get approval from the manufacturer, and you need a procedure to make sure that it's being installed properly. Now, in this section of the CT manual, again, you can see they're going over procedures for working on the landing gear section. And at the bottom of this page here, they say minimum level of certification required, repairman light sport aircraft maintenance, or higher grade certificate. Task specific can be completed by a responsible individual who's received Flight Design airplane operational training. Okay, so Flight Design actually has their own maintenance training that they make mechanics go through. There is a little catch, though, in this, where it says a light sport repairman certificate maintenance or higher. The FAA doesn't like that wording, and they're actually saying that if it says that, there is no higher, that you actually can only be a light sport repairman maintenance rated and perform the maintenance on this airplane that's laid out in this part of the manual. If you're an AMP, you can't do it. If you're an AMP with an IA, you can't do it. If you're a repair station, you can't do it legally, even though we know they meant that when they said or higher. So as a result, these companies are now changing their manuals and including that specific wording. I think Flight Design, they're putting out a bulletin that says that that's what they meant, to make sure everybody who has been working on them is legal, and they're changing all their manuals. So just so you know, that's a little catch that's coming, and you need to check the manuals of the airplanes you're working on and make sure that they include, if you're an AMP, you as an AMP, so that you're actually legal. Now, it is important that you keep good records, accurate records on all the maintenance. Engine logs and airframe logs must be separate because the engine may be removed at some point, and that log will go with the engine, and you'll get a new log with the new engine. Now, types of training that are available from Rotax, they have 3 courses that are very good, very well laid out, and they were actually specified by Rotax what would be in each one of them. Doing the hand thing here, whacking the mic. Service is the first level. It's a 2-day course, and it gives the student the necessary knowledge required to perform routine maintenance up to a 100-hour inspection. It's basically 16 hours of training, and it's very good. Everyone I know that's gone through it has really enjoyed the course. For owners, it's a great intro to Rotax. I mean, I'm going to give you some great information here in 45 minutes or so. Just imagine how much information we can give you in 2 full days. And they pack 2 full days. There's a lot of hands-on. And we actually have our own school at our facility with a dedicated instructor who is back in the back of the room, Dean Vogel, who does a really good job of going through all that information. He'll be available after this presentation if you have any questions. The next level is maintenance level. And maintenance gives the student the necessary knowledge required to exchange components and perform advanced troubleshooting. That's a 2-day module. Of course, the service module is required before you go through the maintenance module. Between those 2 courses, 4 days of training, a mechanic can probably get 90% of the information he's ever going to need to work on Rotax engines. So that's a very time and cost-effective package with those 2 courses. Now, if you want to actually overhaul components, then you need to go through the next step, which would be the heavy maintenance. Because basically at the maintenance level, what you're going to be doing is you're going to be removing components. You can send them off to a repair station like Lockwood, have them overhauled and then returned, and then you can reinstall them on the engine and then return it to service. And in fact, unless you're doing those overhauls every day of those components, cylinder heads, gearbox work, it's probably better to just let a center that does it every day do it, because you'll get rusty. I mean, you need to be doing it on a regular basis to stay current, and it requires quite a few special tools. Now, we do have our next course scheduled June 15th and 16th. There is a service course at our facility in Sebring, and on the 17th and 18th we follow up with a maintenance course. So anybody who's interested in that can head over to our booth or talk to Dean, and they can get you signed up on those. We can only accept a maximum, is it 16, Dean?
16 for the service class, 12 for maintenance.
Yeah, 16 and 12 in those courses, and they do tend to fill up fairly quickly. Now, Rotax has gone through and changed all their manuals for the 9 series in the past couple of years, and spent a lot of time on it, and the results are quite good. The manuals are available online. I'm going to show you how you can get those manuals and download them as a PDF file at no cost. If you go to the Rotax website, on the bottom of this page, here you'll see www.rotax-aircraft-engines.com. That is one place where you can get all the technical information that's available for free. If you go to their website, you're going to see a page that looks just like this. If you look at those tabs across the top and you actually go over here and you click on documentation, then it will pull up a page like this, and you'll have pull-down menu bars. Of course, you're going to typically pick English, 912 ULS, and then in this case I have clicked on maintenance manual, and then this page will come up and you'll see the manuals that are available, and on the right, these PDF files, if you click on those, it'll open the file, and then you can actually print it on your computer. There's another site that's very handy for Rotax information. It's called the ROAN site, which stands for Rotax Owners Association, and that is available at rotax-owner.com. Now, these fellows up in British Columbia have crafted a number of videos, training videos, which help you go through different procedures required to maintain these engines. They're very good. In this case, if you were to click on support and roll down to expanded video instructions, you're going to find some great videos. And there again, you can download those for free. Now, before we move on, I want to go over just a few carburetor tips. The carburetors on the Rotax aircraft engines, the 9 series, they should be synchronized using separate vacuum gauges and rechecked every 100 hours. This should be done by someone who knows how to do it. It is important to make sure the engine idles smoothly. And the reason is you've essentially got two separate engines, really, that are sharing the same crankshaft. You've got two cylinders on one side fed by one carburetor, two cylinders on the other side fed by the other carburetor, very lightweight flywheel. And it's important that those two carburetors are set at the same vacuum. They're throttled with a butterfly. And if one is more advanced than the other, then you're going to have a strong power pulse and a weak power pulse, a strong power pulse and a weak power pulse. And what that causes is it's known as torsional vibration. If the engine is set up properly, the carburetors are balanced, it will idle like a sewing machine. It'll run like a sewing machine, and that's the way it should be. It'll also affect starting. You won't notice it very much at high power settings because things will even out at high power settings. It's at the lower power settings that the carb sync and setting up the idle are so critical. Minimum idle speed is 1400 RPM. The engine has a very high performance camshaft, and it is a high compression engine, so it doesn't want to idle below 1400 RPM. Now realize that at 1600 RPM, which is a typical idle for this engine, you've got only 658 propeller RPM because of the geared reduction drive. So a propeller is still turning quite slowly. You'll pick up about 200 RPM from the time you start the engine till the time it warms up. So if you set your idle at 1600 RPM, then it'll be unlikely it'll go below 1400 when it's cold. So that's a good range. Some heavy propeller designs require an idle of up to 1800 RPM to keep everything smooth, but we don't like to go over 1800 because at that point the choke system, the origining system, won't work because the butterfly won't actually close enough to allow the origining circuit to work. Now that's another tip that I can give you when you're starting these engines in cold weather. If you're going to use what we call the choke, it's actually an enriching circuit. That circuit, what it does is it opens up a valve which allows extra fuel to flow from the float chamber up into the venturi. But in order to make that work, the butterfly that throttles the engine has to be closed almost all the way. So what does that mean? That means if you're using what we call the choke circuit, you better have the throttle all the way back at idle. If you crack the throttle, you will decrease the effectiveness of the choke dramatically. So in cold weather, pull the throttle all the way back, pull your enriching circuit on or your choke on all the way, start the engine. As soon as it lights, you can advance the throttle then and still get some effectiveness out of the choke. It really has almost no effectiveness, though, at high power settings. Now, on some of the airplanes coming over from Europe, and as we know, a lot of the special light sports today are coming in from Europe, they use different antifreeze over there. So it's important to understand the fact that if you see something like this in the manual or on the firewall where it says 80% antifreeze, 20% water, you can't do that with the American antifreeze. Now, U.S. antifreeze will work in these airplanes, but it's mixed at a different density. So with our antifreeze, we typically use a product called DexCool, which is made by a number of different companies. 50-50 with distilled water is the way we mix it. And certainly you can't mix it any richer than 66% coolant. Okay? If you do, some of the particles in that coolant are going to drop out and they're going to form crystals inside the engine and actually impede the cooling. So 50-50 is what we like to see. If you see that on a European style airplane, you don't want to do that with our coolant. Usually after about 200 hours or 2 years, we'll drop the European coolant out and replace it with DexCool, and then from that point on, you can buy it locally. We do stock some of the European coolant for people who need to top off their engines while they're new until they switch. Now, we get a lot of questions about oil because you don't want to use typical aircraft oil in these engines. As I discussed earlier in the presentation, they're really built more like automotive engines, automotive or motorcycle type engines with their tight tolerances and the metallurgy that's used inside the engine. So what we like to use is an automotive style engine with a gearbox additive, and that would be a motorcycle oil. That's the way most motorcycle oils are used today because we use our engine oil to lubricate our gearbox, just like most modern motorcycles do today. In this case, you can see this mechanic is filling up the oil tank with the new Aeroshell product. Now, We have three types of oil that we typically use or get questions about. One would be a full synthetic, and this is one of the best examples of that, Mobil 1. That is an ideal oil if you're going to go with just unleaded fuel. Now, the base stock in Mobil 1 and most of these full synthetic oils, they do not react well with tetraethyl lead. If you use 100 LL, it will tend to cause a lead paste within the engine, which is like a waxy substance, and it literally will plug up the oil passageways and eventually could cause the engine to fail due to oil starvation. So we like to use the Mobil 1 in applications where the customer is only using autogas, unleaded autogas. I mean, you could get a little bit of avgas in there, but you don't want to be using too much. Then we have mineral-based oils, which are less expensive. This is an example of a Pennzoil motorcycle oil, which is available in 2050 and 1040 weights. And those oils tend to be maxed out at 50-hour oil change intervals. You can't go to the 100-hour oil change intervals. And they typically will work with different types of fuel. And then you have the new Shell product, which appears to be a very good product. It actually has the Rotax name on the bottle. It was developed in cooperation with Rotax. It's a 10W40 weight, so it'll work in any temperature range, cold or hot. And it is a semi-synthetic, so it has many of the properties of a synthetic oil, but using Shell's experience with avgas, many years of experience with avgas, they were able to blend a semi-synthetic which will work with avgas. Now, I'm talking about the different fuels here. I just want to mention oil change intervals and how they can be affected by the type of fuel that you are using. If you want to go with 100-hour oil change intervals, it appears that you can do that with this Shell product as well as with the full synthetic products like Mobil 1. But if you want to use avgas and you're using it, say, up to 30% of the time, that's going to whack you back to no more than 50 hours between oil change intervals, regardless of the type of oil you're using. If you're using avgas more than that, primarily avgas, then we recommend oil changes every 25 hours. You got to realize we only have a little over 3 quarts of oil. So with that small amount of oil, we'll get loaded up with lead fairly quickly if you're using avgas. Now, you can use avgas, but there again, you should move to the more frequent oil change intervals. We get a lot of questions about the oil filters on these engines because it is an automotive type filter. However, it is a filter that is specially made for the Rotax application. And one of the differences between this and an automotive filter that you might find at your local auto parts store, and we have had guys go to the auto parts stores and find filters that they can get to fit on this engine. But the bypass ratio, the bypass valve is set at a higher pressure on these filters. The reason for that is in a car, you can stand to have a lower bypass pressure because it's unlikely that you would start your car up and warm it up for a very short period of time and then go to full power and leave it there. Not many people do that in their car. Start it up and get it out of the driveway, warm it up a little bit, and then just firewall it and head to work. What that would do is it would cause your filter to go in bypass. Now, with the Rotax filter, the bypass pressure is high enough and the filtering material is such that as long as your oil temperature is above 120 degrees Fahrenheit, you should not be bypassing the filter element, even at full power. And that's the reason or one of the reasons Rotax requires 120 degree Fahrenheit temperature before you go to full power on the oil. Now, you'll notice that there's a bit of torque seal on this filter. It's a good idea once you've finished tightening the filter to put the torque seal on there. Rotax lists a procedure to tighten that filter, and what they say is that the filter should be, clean the contact surface on the engine, and then put a coat of fresh oil on the gasket on the filter, screw it on, and then when you get solid contact, which is about an eighth of a turn beyond touching solid contact, you go 270 degrees, and that's where they want to see that filter. What we usually do is after we've done an initial run, run the engine for a few minutes to check for leaks after an oil change. It's always a good idea before you cowl your engine up that you do that. You know, run it, make sure nothing's leaking, then go back to the filter and try and screw it off. And if it you know, if it wants to come off, then it needs to be a little tighter. People who live up north often let their airframes sit for the